Hi everyone. Today for your asynchronous lesson, we are modeling compositions. So what you're going to do is work through this entire worksheet. There's the front and the back. If you haven't already gotten it, then you will get it from this page in Canvas. You should download it and print it so that you can work it out on this paper. And then what you're going to do is pause this video, work on the entire worksheet, the whole front and the back, and then you're going to unpause the video to see the solutions as well as my comments about it. So right now, go ahead and get the worksheet ready, download it, print it, whatever you need to do. Pause the video, and then come back to it after you have completed the worksheet. Okay, so what we're going to do when we go over it here is I have the answers written down, and so we are going to go through them, and then I'm just going to talk about a couple of things each time. So first, we have after attending a Carolina Panthers game, Austin noticed the number of fans in the stands seemed dependent on a few other variables, and so that's key. That the number of fans in the stands is going to be our ultimate output here. And so we decided to investigate. We looked at the number of rainy days, the average daily practice time in hours, and winning percentage to determine if we could predict the average number of fans per game. So we have three variables that we're going to explore. R, the number of rainy days, X, the average daily practice time, and W, the winning percentage. So for question number 1, P of R is the average daily practice time. That's our output. And then you can tell that's the output because the way the function is written, based on the number of rainy days R, which is our input. And like I said, you can tell the way it's written that that's the case because we have the R inside the notation. Now, anything I'm writing in red are kind of like notes. So what you guys could do is just take a different color pen out. You can pause the video again to get that ready and then just add notes to your worksheet or your work on your notebook paper. So for A, we just have done stuff like this before. A and B, we solve for the average daily practice time given the input, and then we were provided with the output of 4 hours and then asked to work backwards and find the number of rainy days. Number 2, W of X is the winning percentage, W based on the average daily practice time X. But what I want to point out is that average daily practice time is also P of R. So over here, I'm going to write X equals P of R. And that will help us later when we write this as a composition. So did the same kind of stuff. I used function notation rules to plug it in. But then when we get to B, it says write W of X in terms of the number of rainy days, i.e. as a composition of functions. So remember, if X equals P of R, then I'm going to write W of P of R. And so that's just where I got that from right here when I was showing my work. And that is how we get our winning percentage based on the number of, rainy days. And so this kind of all connects. We have 4 hours, 10 rainy days. And so we asked about 4 hours again. And we could have plugged in 10 to this equation in letter B and gotten the same answer, 77%. Number 3, N of W is the winning percentage. And so remember, another way to write W is W of X. And another way to write W of X is W of P of R. So this is our final composition where we plug one function into another. And so we just start off with something simple. But when we get to letter B, we end up having to plug in the R to the equation from part number 2, get the answer, winning percentage, and then plug the winning percentage in to the number of fans function. And so when we do that, what we're really doing is a composition that we learned a couple of days ago. And so letter C says write the function for N of W in terms of R. So again, N of W in terms of R, W is P of R. And so in the end, what we can do is write basically this is all one big function. We have n of w of p of r was how it all kind of came together. And what I could do in the end is I could just rewrite this as n of r. And so in that case, what that shows me is that if I knew the number of rainy days, 6, I could just plug 6 in for r to this final equation, and I can get the same answer of 0.82. So modeling compositions is just taking compositions that you learned the other day and then giving them a context. So if everything is kind of one thing has to happen in order for the next, and then the next and the next, then we can write it like a composition like this scenario. Now this practice has a couple of examples. The first one you were just interpreting, and so I'll let you look at that answer and check it with yours. Number 2 started to get where we had a little bit more math involved, and so same idea. We wanted to plug 10 in to the overtime and then see how much money he made, and then we can plug the money into the party equation and see how many people he can invite. Or we could make it all one function, and what I could do is do n of 10, 2 times 10 plus 6, and get 26 people based on the number of hours he worked without having to go multiple routes or multiple steps, just all one step there. Make the equation first, and then you can get the answer then that way. With number 3, Mason is a captain of the tourist cruise, so we have the same kind of scenario as the Panthers example. And so in this case, we just want you to pick what the expression d of s of x represents. So what I like to do is just a little substitution. I'm going to find s of x right here, and that is the speed of the ship based on the river current. And so I just kind of, because it's the speed s based on the river current x. And so I wrote that, and then that looked to me like letter A, so I went ahead and picked that. Let's just look at B, C. Well, not D because it's not meaningless, but let's look at B and C and see how we can write those as compositions. So you have the speed of the cruise ship as a function of the rate of the river current. Well, that's just s of x. That's already a function there. And then C, we have the average number of photos taken, that's the P, per passenger as a function of the speed. So as a function of the speed of the ship, K. And so that one I would write P of and S of K, or X, I mean, the speed of the ship. Speed or K, either one. But then this one was the photos, which was not what we were looking for. So that answer was A. All right, well, I hope this activity went all right for you. That's all we have for your asynchronous lesson today. And then tomorrow we will just, for our live time together, we will continue to practice this with each other. So if you need to pause and write anything down, feel free. You can rewind and pause at any time and get all of these answers. I hope you guys enjoyed it. Have a great day. We will see you soon.